Hi, we're going to go through the solutions to the Year 9 Mathematics Quadratics revision. Okay, looking at question 1. The curve shown in the diagram below is the graph of... Okay, so the first thing I note is that this graph has been flipped upside down. So it's been inverted, which means it's going to have a negative coefficient of x squared. So looking at the solutions, I can immediately cross out B and D and E. Having a closer look at the graph, I can see that it's been shifted up the y-axis, so it's crossing the y-axis at positive 2. So that means it's going to have a plus 2 outside of the brackets. So my solution is going to be a negative x squared plus 2. So the negative flips the graph upside down, and the plus 2 moves it 2 units up the y-axis. Having a look at question 2, for the graph shown, the equation of the axis of symmetry and the coordinates of the turning point are respectively... Okay, so we're just going to read the values off the graph. The equation of the axis of symmetry, well, that's the vertical line that cuts the graph exactly in half, so we can see that that's running through x equals minus 1, and the coordinates of the turning point, so the turning point is down here at negative 1 and negative 4. So my answer is going to be x equals negative 1 and negative 1, negative 4. Question 3. The y-intercept of the parabola in question 2 is... Okay, so let's have a look where it cuts through the y-axis, and it's cutting through here at x is 0, y is negative 3. So x is 0, y is negative 3. Our answer is C. The x-intercepts of the parabola in question. Okay, so having a look at the x-intercepts now, it's cutting through at x is positive 1 and x is negative 3. So we're looking for negative 3, 0 and 1, 0. Negative 3, 0 and 1, 0. Our solution is A. The coordinates of the turning point of the parabola whose equation is negative x minus 3 squared plus 2. Okay, so let's think about what this graph actually looks like. So here is our initial y equals x squared graph, and then the changes that are made are the negative coefficient flips the graph upside down, then it is shifted 3 spots to the right, so in the direction opposite to what we expect. So now it's over here, and then it is shifted 2 units up the y-axis. So it's going to look something like that. So it's been moved 3 units across on x and 2 units up on y. So my turning point here is 3, 2. So my answer will be E. Question 6. The curve shown in the diagram is the graph of... So let's see what changes have been made. It's been shifted left, so that's 2 spots. So that's going to be looking for plus 2 inside the brackets. It has not been flipped upside down, so we don't want anything that has a negative coefficient. So we're looking for plus 2 inside the brackets. Our solution is going to be D. The curve shown in the diagram is the graph of, so question 7. So looking at what's happened to this graph. So here we may have originally started with y equals x squared. It's been moved down 2 on the y-axis, so we're looking for minus 2 outside the brackets, and it's been moved right 1, so we're looking for negative 1 inside the brackets. So negative 1 inside the brackets, negative 2 outside. Our solution is A. Question 8. Compared to y equals x squared, the graph of y equals x minus 1 all squared plus 3. Okay, so remember, what in the brackets moves it left or right, opposite to what we expect. So this one has been moved right 1, and what's outside the brackets shifts it up or down in the direction we expect. So this one's gone up 3. It doesn't have a negative coefficient of x squared, so it hasn't been inverted or flipped upside down. So we want right 1 up 3, Right one up 3 is going to be answer C. Question 9. This question unfortunately doesn't have the correct answer, but we'll go through what we would think of to solve it anyway. So we can see we've got a +1 inside the bracket, so that's moving left 1, opposite direction to what we expect, and the -2 outside the brackets means it's down 2. So we want left 1 and down 2, and we can see in the solutions there aren't actually any solution that mentions that answer. Question 10. Compared to the graph of y equals x squared, the graph of -5x minus 4 all squared minus 7. Okay, so step by step, the negative flips the graph upside down, so it's been inverted. The coefficient of 5 makes the graph steeper. Remember, any value coefficient that's larger than 1 makes the graph steeper. The -4 inside the brackets moves it right 4, and the -7 outside the brackets moves it down 7. So we're looking for inverted steeper, right 4, down 7. Inverted steeper, right 4 and down 7 is answer C. Question 11. Label the following quadratic equations as either concave up or concave down. Okay, so concave up looks like this. Concave down looks like this. Concave up has a positive coefficient of x squared, and concave down has a negative coefficient of x squared. So concave up. So the first one's concave up. The second one has a negative coefficient, so it's concave down. The third one has a positive coefficient, so it's concave up. And the last one has a negative coefficient, so it's concave. Oops, I can't seem to get this to right. Concave down. Okay, question 12. For the equation y equals x squared, complete the table and then plot the graph on a set of axes. Right, so when we're inputting an x value into an equation, errors sometimes happen when we have a negative. So the easiest thing is to make sure you input it in your calculator with some brackets. So our first one would be y equals 2 bracket -2 all squared, and the second one would be y equals 2 bracket -1 all squared. So our values are going to be 8, 2, 0, 2, 8, and then we would plot those values on the graph, and I'm not going to do that because my pen's not accurate, and then we would plot our parabola. It would look something like that.